until this point, we have been talking about inferential statistics in a very broad sense. We have looked at hypothesis testing, data cleaning, and learned some foundational concepts about parametric and non-parametric inferential statistical tests. We are now going to begin our discussion of specific tests of inferential statistics. Please note that we will not be covering every possible test of inferential statistics in this course. Instead, we will be focusing on those tests you are most likely to encounter when reviewing and critiquing the literature, and those tests that you would most likely be using should you be engaging in data analysis. You will not be expected to compute these tests. However, you need to develop a general understanding of when each of these tests we discuss over the next few lectures should be used. In this first lecture, we will be discussing parametric tests for comparing group means, also often referred to as tests of mean differences. In healthcare, this often involves comparing one group to another or comparing different treatment methods to determine which is more effective. Following this lecture, students should be able to explain when to use tests of mean difference in statistical analysis. Students should be able to distinguish between when to use each of the 3 t-tests discussed in this lecture, list the assumptions for each t-test discussed, and describe what results to report for each t-test discussed. Tests of mean difference are the category of tests that you will want to use when you are comparing group means and your dependent variable of interest is at the continuous or interval or ratio level. If your dependent variable of interest is categorical, such as nominal or ordinal, you will not be able to compare means, as categorical data does not lend itself to mathematical analysis such as means. We are going to discuss 3 different tests for comparing group means. All 3 of these are called t-tests. Well, there are more tests for comparing group means and tests for comparing more than 2 means. These are rarely seen in the literature and beyond the scope of this course. So therefore, we will focus on the 3 t-tests. Choosing the correct t-test to use depends on what you are comparing the means to. Are you comparing the group mean to a known population mean? Are you comparing 2 groups to each other? Or are you comparing a group to itself, such as in a pre-test, post-test design? We are going to discuss each of the 3 types of t-tests. With each test we discuss, we will review what type of comparison the test is used for, the assumptions of the test, what a general null and alternate hypothesis requiring this type of test for analysis would look like, how to interpret the test results, and how to report the test results. We will begin with the one sample t-test. The one sample t-test is the simplest of the t-tests and compares the sample mean score of a chosen dependent variable to a known value, which is usually a known population mean. So this test would be used in a situation where you know the population mean. Say we are looking at the average age of registered nurses, and we know the average age for the United States. And we want to compare the average age of nurses in our sample to the average age of nurses in the United States. There are 3 assumptions of the one sample t-test that you must check before running this test. First, you must know the population mean. We cannot compare a sample mean to a population mean if the population mean is unknown. Second, the sample must be randomly selected from the population, and subjects within the sample must be independent of each other. In other words, no participant should have been sampled or measured more than once. And third, the dependent variable must be both continuous and normally distributed. For a one sample t-test, the null hypothesis would generally say there is no difference between the sample mean and the population mean. The alternate hypothesis would generally say there is a difference between the sample mean and the population mean. As with all tests of statistical analysis, you would use software such as Microsoft Excel or IBM SPSS to compute the test statistic for the one sample t-test and the associated p-value. If the p-value is smaller than our chosen alpha level of significance, we will reject the null hypothesis and say that there is a difference between the sample mean and the population mean. If the p-value is larger than our chosen alpha, we will accept the null hypothesis and say that there is no significant difference between the sample mean and the population mean. To report your analysis using a one sample t-test, you want to report the test statistic from your statistical output and the associated p-value along with the corresponding confidence interval based on your alpha level. You should also include the mean and standard error for your group so the reader can understand how the sample statistic for the group is different from the population parameter. You should report a Cohen's d, which is a measure of effect size, which we talked about in a previous lecture. Remember, it is important to report both the p-value and the effect size because the p-value will speak to the statistical significance of your results and the effect size will speak to the clinical significance. The independent sample t-test is used when there are two independent groups whose means you are going to compare. By independent groups, we mean that the subjects or members of one group cannot be subjects or members of the other group. Each subject or member is in one and only one group. There are 4 assumptions of the independent sample t-test that you must check before running this test. First, the sampling distribution should be normal. Second, the data should be continuous, which means measured at the interval or ratio level. Third, measurements should be independent, as we just discussed. And fourth, variance in the groups being compared should be about the same. Recall we discussed how to assess for variance in our lecture on parametric and non-parametric tests. For an independent sample t-test, the null hypothesis would generally look something like a statement saying there is no difference between the two group means. And the alternate hypothesis would generally look like a statement saying there is a difference between the two group means. As with all tests of analysis, you would use software such as Microsoft Excel or IBM SPSS to compute the test statistic and associated p-value. If the p-value is smaller than our chosen alpha level of significance, we will reject the null hypothesis and say that there is a difference between the two group means. If the p-value is larger than our alpha level of significance, we will accept the null hypothesis and say there is no significant difference between the two group means. To report your analysis using an independent sample t-test, you would include the test statistic and the associated p-value along with a corresponding confidence interval based on your alpha level. You should include the mean and standard error for each group so the reader can understand how the two sample means differ. You should also report Cohen's d, which is a measure of effect size that we talked about in a previous lecture. Remember, it is important to report both the p-value and the effect size because p-values speak to statistical significance and effect size speaks to clinical significance. The dependent sample t-test is used when the measurements of a given dependent variable are paired. In other words, you have one group of participants. This can occur in a pre-test, post-test design where the same sample is measured twice, usually before and then again after an intervention, or in a situation where the same group is measured using 2 different measurement tools, such as comparing temperatures using an oral thermometer and a temporal thermometer. The dependent sample t-test will have the same assumption of normal sampling distribution and continuous level data as the independent sample t-test. However, since the groups are not independent, we will not have the assumptions of independent measures or variance in the groups being the same. A key point for understanding here is that since we are comparing the difference between the two sets of measures, either the difference from pre to post or the difference between the output of the two different tools, the difference values are what must be normally distributed and continuous. For a dependent sample t-test, the null hypothesis would generally look like a statement saying there is no difference between the two measurements. The alternate hypothesis would generally look like a statement saying there is a difference between the two measurements. As with all tests of analysis, you will use software such as Microsoft Excel or IBM SPSS to compute the test statistic and associated p-value. If the p-value is smaller than your chosen alpha level of significance, you will reject the null hypothesis and say there is a difference between the two group means. If the p-value is larger than your alpha, you will accept the null hypothesis and say there is no significant difference between the two group means. To report your analysis when using a dependent sample t-test, you would include the test statistic and the associated p-value along with a corresponding confidence interval based on your alpha level. You should also include the mean and standard error for each group so the reader can understand how the two sample means differ. You should also report Cohen's d, which is a measure of effect size, which we talked about in a previous lecture. Remember, it is important to report both the p-value and the effect size because p-value speaks to statistical significance and effect size speaks to clinical significance. In summary, t-tests are the set of parametric tests used to compare two group means. These tests allow us to make comparisons between groups on a single dependent variable, and the variable must be continuous for us to compare means. A one-sample t-test allows us to compare a group mean to a known population mean. An independent sample t-test allows us to compare the group means of two independent groups or two groups that do not have any overlapping members. A dependent sample t-test allows us to compare the differences in group means from either before to after an intervention or across two tools or interventions. Remember, you must always check the assumptions of your chosen test. If the assumptions are not met, you will want to use the corresponding non-parametric test, which we will discuss in our next lecture.